Have you ever noticed how the sky changes? Who knows, maybe the first disappointment of your life was the time that you saw a giant dragon made of clouds flying over the sky, and before you could reveal this bombastic news to society, the dragon vanished. And in his place is a little white rabbit. But you are not alone. In fact, many people have as a profession to look at the sky and document its changes. Meteorologists have invented fancy names that look more like Harry Potter spells for the cloud shapes you saw as a child, like cirrus, stratus, and autocumulus stratiformis translucidus radiatus. They also invented methods for counting the amount of clouds in the sky just by looking up. The fact is that clouds are extremely important. Its physical properties, which varies from each cloud type to cloud type, are able to change the amount of radiation that reaches the ground and go off to space. Thus, it is not difficult to imagine the clouds play an important role in phenomena such as urban heat islands and climate change. To really understand how clouds interfere with the heat balance, we need to study them. All sky cameras are like clouds paparazzi. With this camera, which have a fisheye lens, we can take pictures of the whole sky in every moment. Now we have an immense image database of the sky, and we can apply algorithms to identify the amount of clouds and its thickness, which are essential parameters to understand the radiation that reaches the surface. And that's what we are currently working on. We placed two all-sky cameras, one in the Scientech Park and the other in the Botanical Institute, and we have been taking pictures of the sky for over 6 months. Comparing the results between the two cameras, they were very consistent. However, life is not a bed of roses. Remember that some meteorologists can classify the sky just by looking up. We compare our results with their observation, and it was not very satisfactory. Two main problems have been identified. The first is that thin clouds are not being well represented. We use two algorithms, the CDOC and the BRBG. They compare the RGB value in each pixel for what is defined as cloud or sky. The CDOC algorithm can separate clouds into thin and thick clouds. We noticed that sometimes the CDOC algorithm classifies thin clouds as thick clouds. We are currently studying the algorithm's parameters that defines what is thick and thin clouds and readjusting so that thin clouds can also have their spotlight. The second problem is familiar to anyone who has ever tried to take a direct picture of the sun. Lens flare, which are sometimes desirable, have become our worst enemies. These spots changes the true color of the sky and prevent clouds from being recognized. Even worse, the fisheye lens geometry deforms the lens flare and make it look even bigger when the sun is close to the horizon. But we are Brazilian and we never give up. We are currently working on a way to edit the image and erase the lens flare. The results already look promising. The fact is that more and more our sky cameras are being used in different fields of science, and they can be an immense advantage as they can monitor the sky almost continuously. With a camera and a computer, the subjective factor linked to the human eye is eliminated. We have the same results regardless of who is operating the machine. Isn't that right, neighbors?